Number 1. PAN, Personal Area Network. The network you carry everywhere and you don't even notice it. Right now, your phone is talking to your earbuds. Your smartwatch is syncing with your fitness app. Your laptop might be connected to a wireless mouse. All of this is happening silently in a bubble around your body, and that bubble has a name, the Personal Area Network, or PAN. A PAN is a short-range network built around a single person, typically covering a radius of about 10 meters. It connects your personal devices to each other using technologies like Bluetooth, Zigbee, or USB. The concept was first formalized by IBM researcher Thomas Zimmerman in 1996. Today, over 5 billion Bluetooth devices are active worldwide, all operating inside personal area networks. The PAN isn't just a feature, it's the invisible web of your digital life, and it follows you everywhere. Number 2. LAN, Local Area Network. Every school, every office, every gaming setup, they all run on the same secret infrastructure. The Local Area Network, or LAN, is the backbone of modern buildings. It connects devices within a limited physical space, a home, a school, an office floor, and lets them share data, printers, files, and internet connections at extremely high speed. LANs became mainstream in the 1980s when Ethernet was standardized by IEEE as 802.3 in 1983. Today, modern wired LANs can hit speeds of 1 to 10 gigabits per second, fast enough to transfer a full HD movie in under a second between two computers on the same floor. Here's what makes LANs powerful. They are privately owned and managed, which means full control over speed, security, and access. No public internet bottleneck, no ISP in between. Just raw, direct speed between devices sharing the same space. Number 3. WLAN, Wireless Local Area Network. You're using one right now, but most people have no idea how it actually works. A wireless local area network, WLAN, is simply a LAN without the cables. Instead of Ethernet wires, it uses radio waves to connect devices within a local space. What you call Wi-Fi is actually a WLAN. The technology was born from the IEEE 802.11 standard, first released in 1997. Since then, it has evolved dramatically, from 802.11b at just 11 megabits per second, all the way to Wi-Fi 7, or 802.11be, which can theoretically deliver speeds exceeding 46 gigabits per second. Today, over 20 billion devices are connected via Wi-Fi globally, according to the Wi-Fi Alliance. But here is the trade-off. Wireless LANs are faster and more convenient than ever, but they remain vulnerable to interference, congestion, and security attacks in ways wired LANs are not. The wire disappeared, the limitations didn't. Number 4. CAN, Campus Area Network. It's bigger than a building, smaller than a city, and it's why your university or hospital just works. A campus area network, or CAN, connects multiple buildings across a defined geographic area. Think a university campus, a hospital complex, a military base, or a large corporate headquarters. It is essentially several LANs linked together under one controlled infrastructure. CANs typically span anywhere from a few hundred meters to several kilometers. They use high-speed fiber optic cables as the backbone, often combined with wireless access points for flexible coverage. A well-designed CAN allows a student in one dorm to stream seamlessly from a server in the library, or a doctor to pull up patient records from any wing of the hospital in milliseconds. Unlike WANs, which depend on external internet providers, a CAN is privately owned, meaning faster speeds, tighter security, and complete control within the campus perimeter. Number 5. MAN, Metropolitan Area Network. What connects all the Wi-Fi hotspots, offices, and data centers scattered across an entire city? One massive network most people have never heard of. A Metropolitan Area Network, MAN, is designed to cover an entire city or large region, typically spanning 5 to 50 kilometers. It sits right between the local reach of a LAN and the global scale of a WAN. Cities use MANs to connect government offices, hospitals, universities, and public Wi-Fi zones into one seamless network. Cable TV providers, fiber internet companies, and citywide surveillance systems often run on MAN infrastructure. Technologies like fiber optics and WiMAX, standardized as IEEE 802.16, are commonly used to build them. In countries like South Korea and Singapore, city-scale MANs have helped achieve national average internet speeds that regularly rank among the world's fastest. The man is, in many ways, the hidden nervous system of a smart city. Number 6. WAN, Wide Area Network. Without this one type of network, the internet as you know it would simply not exist. A wide area network, WAN, spans massive geographic distances, crossing cities, countries, and entire continents. The internet itself is the largest WAN ever built. Unlike LANs, which are owned by individuals or companies, WANs are typically built from leased infrastructure, undersea fiber cables, satellite links, and long-distance telecom lines. Over 400 undersea cables currently carry roughly 99% of all international internet traffic. Corporations use private WANs to connect offices worldwide. When you video call a colleague on the other side of the planet, your data is traveling through a WAN in real time. Technologies like MPLS, SD-WAN, and leased fiber lines power these connections. The WAN isn't glamorous, but it is the reason a message typed in one country reaches a server on another continent in under 200 milliseconds. Number 7. VPN, Virtual Private Network. Millions use it for privacy. Governments use it for security. Corporations use it to link employees worldwide. But almost nobody understands what it actually does to your data. A virtual private network, VPN, creates an encrypted tunnel between your device and a remote server, making your traffic appear to originate from a different location. It is not a physical network. It is a secure, private layer built on top of an existing public network like the internet. VPNs were originally developed in 1996 by Microsoft engineer Gurdeep Singh Paul through the point-to-point tunneling protocol. They were first designed to let employees securely access company networks remotely. Today, over 1.6 billion people use VPNs globally. They encrypt data using modern protocols like OpenVPN, WireGuard, and IKV2. But here is what most VPN ads won't tell you. A VPN protects your data from your ISP, not from the websites and services you actively visit. Number 8. SAN, Storage Area Network. When Netflix loads your movie in seconds, when hospitals pull up scans instantly, when banks process millions of transactions without pause, there's a network behind the scenes nobody talks about. A storage area network, SAN, is a high-speed, dedicated network that connects servers directly to large pools of shared storage, disk arrays, tape libraries, and flash systems. Unlike general-purpose networks, a SAN is built for one purpose: blazing fast, reliable storage access. SANs use technologies like Fibre Channel, operating at speeds up to 128 gigabits per second, or iSCSI over standard Ethernet. Because SAN storage appears to servers as locally attached disks, it delivers significantly lower latency than cloud or network-attached storage. According to IDC, the SAN market is valued over $20 billion, deployed heavily across finance, healthcare, and media industries. The SAN is the unsung hero behind every enterprise that cannot afford even 1 second of data downtime. Number 9. VLAN, Virtual Local Area Network. What if you could split one physical network into multiple isolated private networks without touching a single cable? That is exactly what a virtual local area network does. A VLAN segments a physical network into logical, isolated groups. Devices on the same VLAN communicate freely with each other, but are completely cut off from devices on a different VLAN, even if they are plugged into the same physical switch. VLANs are defined by the IEEE 802.1q standard, introduced in 1998. A single network switch can host up to 4,094 VLANs simultaneously. In a hospital, patient data, visitor Wi-Fi, and medical equipment all share the same physical infrastructure, but VLANs keep them completely isolated. In a company, HR, finance, and engineering teams coexist on the same hardware while remaining securely separated. VLANs give network administrators the power to enforce security and reduce congestion, entirely in software. Number 10. HAN, Home Area Network. Your home is a network, and it's getting smarter, more complex, and more vulnerable every single year. A home area network, HAN, connects all devices inside a residential space: your phone, laptop, smart TV, security cameras, smart speakers, thermostats, and more. It is typically managed through a home router using Wi-Fi, Ethernet, Bluetooth, or Zigbee. HANs existed long before smart homes. Even a simple router connecting a laptop and a printer counts. But the explosion of IoT devices has made hands far more complex. By 2025, the average household in developed countries has over 20 connected devices operating on the home network. This complexity brings real security risks. A poorly secured hand means your baby monitor and your banking app share the same network. One compromised smart bulb can be the entry point for an attacker to reach everything else in your home. Number 11. SDN, Software Defined Network. Traditional networks are locked in hardware. SDN threw that rulebook out the window, and it's changing everything. Software-defined networking, SDN, separates the control plane, the brain that decides where traffic goes, from the data plane, the hardware that physically moves it. Instead of each router and switch making independent decisions, a centralized software controller manages the entire network from one place. SDN was pioneered at Stanford and UC Berkeley in the mid-2000s through a protocol called OpenFlow. It gained commercial traction as cloud computing exploded and traditional hardware-based networks became too rigid to scale. Google uses SDN to manage traffic across its entire global backbone, shifting data flows in real time to optimize performance across continents. It powers the agility behind cloud platforms like AWS and Microsoft Azure. In a world where network demands change by the second, SDN replaces the rigidity of hardware with the speed of software. Number 12. CDN, Content Delivery Network. You've loaded YouTube, Netflix, or Instagram in under a second from thousands of miles away. Ever wonder why it doesn't take minutes? The answer is a CDN. A content delivery network is a geographically distributed group of servers that store cached copies of content, videos, images, and web pages closer to end users. Instead of every request traveling to a central origin server, the CDN delivers content from the nearest edge server. Akamai, one of the world's largest CDNs, operates over 350,000 servers across 130 countries. Cloudflare CDN handles roughly 20% of all global internet traffic. Without CDNs, a single viral video could overwhelm and crash its origin server within minutes. CDNs also cut latency dramatically. If an origin server is in New York and you are in Lahore, a CDN edge server in the Middle East serves your request, cutting delivery time from over 150 milliseconds down to under 30. Speed is geography. CDNs solve both. Number 13. IoT Network, Internet of Things Network. By 2030, there will be over 29 billion connected devices on Earth. Not phones, not laptops, things. And they all need a network built specifically for them. An IoT network is infrastructure specifically designed to connect billions of low-power, often low-bandwidth devices, smart meters, industrial sensors, traffic lights, agricultural monitors, medical implants, and more. Unlike standard networks built for fast human use, IoT networks prioritize three things: low power consumption, wide coverage, and massive device density. Protocols like MQTT, LoRaWAN, NB-IoT, and Zigbee are purpose-built for these constraints. LoRaWAN, for example, can connect a sensor up to 15 kilometers away on a single battery lasting several years. NB-IoT, developed by 3GPP, allows devices to operate at the edge of cellular coverage while consuming almost zero power. IoT networks are the invisible nervous system of smart cities, precision agriculture, industrial automation, and modern healthcare. They don't just move your data, they move the world. Number 14. EOP, Ethernet over Power. What if the electrical wiring already inside your walls could carry your internet connection? That's not a future idea. It's been working for decades. Ethernet over Power, also called power line networking, uses your home or building's existing electrical wiring to transmit data signals alongside the electrical current. You plug one adapter near your router, another near your device, and they form a network connection through the power lines. No new cables needed. The HomePlug AV2 standard, ratified in 2012, pushed power line speeds to a theoretical 2 gigabits, with real-world performance typically between 200 and 500 megabits, more than enough for HD streaming and stable gaming. EOP is especially valuable in older buildings where running new Ethernet cable is impractical or expensive, and where Wi-Fi struggles due to thick concrete or brick walls. It is not as fast as direct Ethernet, but it solves a real problem elegantly. The infrastructure for your internet was already built before you moved in. Number 15. BAN, Body Area Network. The next frontier of networking isn't in the cloud, it's on your skin and inside your body. A Body Area Network, BAN, is a network of wireless sensors and devices operating on, around, or implanted inside the human body. It is defined by the IEEE 802.15.6 standard, specifically designed for low-power, short-range communication within the proximity of a human body. In healthcare, BANs are already saving lives. Continuous glucose monitors, cardiac implants, and wearable ECG patches communicate in real time with hospital systems through BAN technology. In military applications, soldiers' vital signs are monitored on the battlefield through wearable BAN sensors. The communication range is typically under 2 meters, using technologies like Bluetooth Low Energy and ultra-wideband. Power efficiency is critical. Many BAN devices must run for months or years without a battery replacement.
Number 16. POLAN, Passive Optical LAN. What if you could replace thousands of meters of copper cable in a building with a single strand of glass and cut your energy bill by 60%? POLAN, Passive Optical LAN, replaces traditional copper Ethernet infrastructure inside buildings with fiber optic cables and passive optical splitters that require no electrical power to operate. A single optical line terminal can serve up to 512 devices using just one fiber strand. Unlike traditional LANs, where each device requires an active switch consuming power continuously, POLAN uses passive splitters, meaning no power supply, no cooling, and no maintenance for the distribution layer. The U.S. Department of Defense has deployed POLAN extensively in military facilities, reporting dramatic reductions in both infrastructure cost and energy consumption. Industry studies show POLAN can reduce total cost of ownership by up to 50% compared to traditional Ethernet LAN, particularly in large campuses, hotels, and hospital complexes. It is not just a better LAN, it is a fundamentally smarter way to wire a building.
If you found this helpful, a like and subscribe means the world. It helps more people find this content.